CoolerControl is an app I've been using now for a good 6 months to a year, I think. I've been extremely happy with it, and I thought I'd just feature it now. So this is not going to be a self-hosting type service. And remember also, as usual, it's not going to be a how to install type video either. I'm going to really be looking at what it does, why you may be interested, what does it look like, what are some of the settings, and so on. And you can decide then if you really want to install it. It's actually got a tremendous amount of functionality, and I'm really only going to be scratching on sort of some of the superficial stuff that I'm really using every day. So let's kick off then with what it actually does. It is a graphical user interface, and it's for Linux desktops. So yeah, sorry if you are Mac OS or Windows, then this is not going to be for you, this video. But you might want to just have a look and compare whether you're getting the same sort of functionality on the Windows and the Mac side. I think certainly that CoolerControl can stand at the top when it comes to all these various types of applications across the operating system. Sometimes Linux users have to do with second best, but in many cases you will find some of the open source apps that are produced because the OEM or the manufacturer hasn't provided an actual interface for Linux have done a better job of functionality and look and feel and so on. And CoolerControl is an example of that. It really gives you a tremendous amount of functionality over your cooling and monitoring and that sort of thing. And really is a top-class app. It can also make your computer quieter and more efficient. So what often happens is generally a lot of the fan curves and things that work with cooling, they tend to work in a sort of a linear type curve. So even if your computer is working at, say, 40-50 degrees, which is now not hot yet and it doesn't really require any cooling, the fans are often already running at 25-30%. So it's just adding that sort of background noise and so on the whole time. So you'll see when we look at my curves just now, I've adjusted them really to start the fans working when it's starting to get a little bit warmer and it should be starting to cool. So I apply a little bit of fan then, and obviously if it's heavy loads, I'm using a sharper curve to then just crank it up to, 70-80% and even 100% when necessary. And obviously as well, you've got a lot more control then over how your cooling and so on works. It does detect the various hardware sensors for things like CPUs, GPUs, fans, liquid cooling systems, motherboards, and so on. So that is a bit of a prerequisite. Obviously, you've got to have the Linux drivers activated and installed for exposing those hardware sensors. And usually that's just a setting that you've got to do once or so and you forget about it. I can't remember when I've last had to touch mine, in fact. But the setting's already there, so it will be able to work with those various sensors to determine temperature and fan revolutions and that type of thing. And then what you really do is you're configuring single or mixed profiles for each device. So, for example, normally your CPU fan is going to be working with the CPU temperature. That's the standard BIOS sort of setting. But say, for example, you actually wanted your case fans to also come in and start assisting the CPU fan, or maybe just a small amount of assistance, or maybe you want to make it go even faster. The point is you can mix and match. So you can use one sensor in terms of, say, it being CPU, but you can apply multiple fans to do the cooling. And in my case, for example, a very good example of this really is I've got one of those NVMe drives, the little solid state drives on my motherboard. Now that's got no cooling whatsoever. So it relies on the system fans really to keep it cool. So in this case, I'm using the NVMe temperature as a sensor, and I'm applying that also with the case fans. So if it starts getting too hot, I'm cranking up the case fans to help cool it down. So this mixing and matching of profiles is actually quite a powerful feature that CoolerControl has got. And then configuring of alerts for monitoring. So you can have warnings for, if certain of your devices like your CPU or your graphics card is getting too hot. You'll obviously hear the fans, I suppose. But something that I have got configured for alerts there is, for example, if my CPU fan is at 0%, in other words, it stopped turning, because I'm always wanting it. I basically keep it turning slowly the whole time anyway, regardless of the temperature. But I need to know if that fan is actually broken or if something's gone wrong with it. So I'm actually monitoring its revolutions as well as an alert. And you can show some device stats on graphs and that sort of thing over time as well. So that really is in a nutshell what it does at a very high level. The features, okay, I'm not going to go through all of this. This is not even an entire list. There's an even longer list of actually what it does. So it just gives you an idea of, the depth and breadth this goes into. It is open source on GitLab. I've already mentioned it's Linux desktop, so it'll also work on servers. It has got a couple of options for installing app image, the various distros like Arch, Ubuntu, Fedora, that sort of thing. There's a Docker image as well, and it'll also install on Unraid. It is highly configurable, so that is something you certainly will notice. There's all sorts of configurations. There's modes, profiles, functions, and other sort of offsets and things that you can set and configure for it. It's a very modern looking graphical user interface as well, with not just one dashboard. You can have multiple dashboards to switch between them as well. So again, quite a plus, I think, for the software. The daemon runs in the background in headless mode. So that is always how it's going to operate. It'll always run in the background. Typically, the application that you're going to open up is really just a browser, maybe an Electron. I can't remember what sort of application it is, but it's actually just connecting with a HTTPS browser link to actually access the data, control it, and to view everything. So that brings it to another advantage it's got then. Because it can work in headless mode, you could also install this, the daemon itself, you could install on a server where it runs as a process, and you could use SSH remote and point with your browser, just point to the server and actually view what you need to look at. Just remember though that alerting, if you don't have the front-end application open and connected with that SSH, you're not going to get any alerting. So, don't rely on that if that's going to be fairly critical, but you can monitor, you can tweak and set and that sort of thing. I've already covered the various temperature and combinations of sensors. It is fully customizable. Each profile, normally the standard default everybody is used to is a graph profile. So, you get that sort of typical curve. As the temperature goes up, this is how the fans then will react. But there's also a fixed speed. I'll show some of these as well. I have touched on the mixed one already, where it will be multiple sources. And there's also an overlay version that can be applied to multiple fans. You can also do a lot of tweaking around thresholds, directionality, and so on, so that you can sort of tweak how it's going to respond. It doesn't have to just be a either or. You can allow some flexibility here, in other words, before the fans actually respond. And that also stops things like it stepping up and down quickly the whole time. Then you've also got things like system-wide cooling mode, so just all devices at once. There's custom sensors, multiple dashboards, and a comprehensive API as well for integrating. So you can have various other third-party applications that can integrate with CoolerControl to provide alternative dashboards, alternative controls, etc. as well. And just the last sort of one I want to go through is just quickly just mention the basic steps to use it, because on first installation, it can be a bit overwhelming. There's a lot of things on the screen, and the point just is, where do you start? What do you do? Well, the prerequisite really is you need to have your Linux hardware sensors exposed. So whether it's HWMON or MVML or liquid CTL, that's for liquid cooling devices, or whatever else you're using, the hardware sensors could be in the GPU, it could be on the motherboard, it could be whatever. They just need to be exposed. Then your next important step is you're going to install the GUI app. So typically you install CoolerControl. Depending on your distro, the daemon should also be, which is CoolerControl D, the process. That's the process name. That should be installed and active at the same time. But essentially, you need to make sure that both of those processes are actually running. So you want to check that the daemon process is running, and you can use a command like this: systemctl space status space CoolerControl D, which is that daemon process. That will just tell you if the status is all okay and it's working fine and so on. Then you know that the background process is running. What you then want to do is just start up your actual application, the CoolerControl. So whether you run it from the menu or you just run CoolerControl from the CLI, it should start up in the graphical user interface, and you should at least see a couple of devices there, like your graphical card, your motherboard, with a couple of sensors. That's the most important thing. If you're not seeing that, you'd have to go back to step one. And there's a lot of help in their documents as well, talking about how to get this all working and so on if you get stuck with it. And then essentially all you're really doing is you're adding a profile per device. So you'd add a new profile, for example, for the case fans, or for the CPU fan, or for the GPU fan, or for the cooling system, or whatever the case is. And as I said here, usually it'll be the graph type, and I'll show that to you in a minute. And then you will, for that profile, you will link it to the device or devices that are going to be monitored. So the CPU fan may be linked to the CPU temperature. The GPU fan may be linked to the GPU sensor. But if you're going to be taking the mix status, you might say, I want the case fans linked to the CPU and to my NVMe temperature. That's how you will set that up. And then you'll set up some alerts if you want to, based on temperature or fan speeds. And you can also alternatively use this browser address, localhost being your local machine, port 11987. That should then also open up the same view as the application. And I'll show that also just now in a minute when we have a look at it. But I think, yeah, let's sort of just look quickly at the documentation, and then we'll jump into the application itself. So this is their documentation. You'll see the address up the top here. It's docs.coolercontrol.org, and I'll have that link also in the description below the video. But there's a wealth of information here, and I see they've got sort of quick jumps to everything as well as to sort of how to get further assistance on any of these particular topics. And typically you're going to start at the getting started. You'll see a bunch of info here on basic setups beautifully. It's all beautifully laid out. Very easy to find information on, say, NVIDIA GPUs, AMD GPUs, specific laptop issues, alerting, disabling of sensors, frequently asked questions, and so on. So I'd encourage you to read this website a little bit. As I said, very, very easy to use. It's really some of the better documentation that I've seen for open source projects. So well done, CoolerControl, or should I say CoolerControl community, actually. So let's have a look at the application, I think. So this is the CoolerControl application screen that you're going to see. You'll see it's running at the moment in a window. I'm going to make it full screen just for the purposes of displaying it, and at the end I will show you the browser view just to show you it's exactly the same as this, but let's just make that full screen. Don't be put off by too many buttons here. There are unfortunately sort of more than one way of getting into things, so you could sort of take it from the view that it's easier to get things done because it's sort of intuitive, whichever particular way you approach it, but you might not be using it exactly the same way, then as I use it. But let's start off and have a look at the sensors here at the bottom, because these are the things that you should be seeing as you come into the system. So in my case, it's got 4 groups of sensors. One is my AMD CPU here. The other is my NVIDIA GPU. The IT8655 is my motherboard, all the various motherboard sensors. How do you remember that? Okay, you can do this. Just to show you as well, we can already start customizing here. To remember this, I'll just type in motherboard. Okay, and there you go. It's changed to motherboard. So now it's a little bit easier sort of to understand. You can also click on the little eye here to get further information about each of your devices as well. And of course, you can expand them. So this is my NVMe solid state drive here. On the solid state drive here, it is measuring temperature. It normally starts off with the first one being the main sensor, and there can be possibly secondary sensors. So I'm not sure if these are different sensors just showing the same temperature, but just take note of that. You'll often use the top one. On the motherboard side, it's got a couple of different temperature sensors. So on the motherboard, these things have got sort of strange names, and if you can work out which they are actually for, remember again, you can go here and you can rename it and give it some simpler name just to remember what it is. So you can make this your own, really. You can also change the color and various other things to make this sort of easier to understand. It's also got, I've got a little fan hub on my motherboard. So it is picking up here things like, for example, the CPU fan. It's all part of the motherboard sensors. The front fans on the case and the rear fans on the case. And it's already showing you here that, for example, well, they're actually all running at 30%. I'm working on percentage at the moment. They've got slightly different revolutions, but that's really what the motherboard sensor is showing you. The GPU, again, main temperature. It gives you a couple of other stats here: temperature, memory, video, power. There are the two fans as well on the GPU, and you'll see at the moment they're running at 0, keeps things quiet. On the CPU itself, the CPU does have sometimes, well, I think it's got two different sensors, yes? The TCTL and the TCCD1 sensor. So I think I'm using the TCTL sensor as my main reading, but you can blend those two together and average them if you want. There's all sorts of things you can do. And it's also monitoring power and load and so on. So those are the sensors that I've got to work with. You may have more. Then the other thing I really want to show is the profiles, because this is really what triggers things depending on what these sensors read. So let's have a look at those. Let me just show you here quickly. Under profiles, I've got a couple already created, and once again you can rename them and so on over there. But you'll see on the right here, you've got a button there that you can click saying add profile. That is where you would add a new profile. Give it a name, choose what sort of profile it's going to be, and it does tell you here just below which each of those is, whether it's a fixed, it's a default, a graph, a mix, or an overlay. I'll show those just now on one of my sensors. It'll make more sense then. But what I meant was here, one way was to go up there and click plus. The other one is you could click over there and add profiles and so on from this side menu as well. So there are a couple of ways of doing it. But on the CPU profile, I created it. I called it CPU temp profile. I've defaulted everything to my function, but you can actually have multiple functions there as well if you want. This is where you link it to the source that's going to be monitored. So in this case, it's the CPU temperature, and I'm just linking it to the CPU sensor. You'll see there's your pick list of your sensors you could choose. I've chosen the main CPU sensor. I've chosen the graph type. So what I've done is the CPU, I'm keeping it running at 30%. It just idles basically to keep it cool. And the reason why was, remember I mentioned I've got an alert looking at when it drops below 5 or 10%. So if I had it running at 0 up to here, I wouldn't really know if the thing was broken. So I've given it a mandatory 30%. It's quite quiet, and you'll see it's keeping the temperature already at 48.9, 50 degrees, give or take. And that is now while I'm video recording as well. So I'm actually then from about 61, 62 degrees, I'm starting to raise my fan speed, and I'm just starting it fairly gently. But if it's not having the effect and the temperature's already reached 76%, then I start cranking the percentage up quite quickly to 100. And already from 85 or so, I'm running at max at 100. So that is my very basic sort of CPU temperature profile. And obviously, what you would have to look at is your own CPU and see what its temperature thresholds are, because you want to be at 100% fan before you get to the maximum temperature threshold for your CPU. Otherwise, it's going to throttle back anyway, and your machine's going to slow down quite dramatically. So the GPU graph is fairly similar. You'll see in this one's case, I've got it off until it reaches above 60 degrees, because if I'm not really using the GPU much, it'll be normally 55, below 60 degrees, and its curve looks slightly different. That's just how I've set it up. The NVMe profile is the hard drive, that NVMe solid state drive. Now it's running at 42 degrees at the moment, so nothing serious. But essentially I'm saying that fans related to this one are going to be staying at 20% if it is below 50 degrees. And only as it starts rising above that are the fans going to start taking off. This is the mix. This is the combo profile that I've got set, and I've named it there Combo CPU NVMe profile. What's happening with this profile is the difference here is we're not choosing sensors anymore. It's a mix profile. You'll see here on the right, mix profile, and it says there combines multiple profiles that already exist. So I've got those three other ones I've mentioned, the CPU, the GPU, and the NVMe. I chose mixed over there. What it then offers you here is not the sensors, but it asks you which profiles do you want to blend and mix. So I've said I want to combine my CPU and my hard drive, the NVMe profile. If either of those are starting to go up in temperature, then apply the necessary curves to the case fans to cool it. The point is, because the CPU fan is not going to have any difference on the motherboard or the NVMe drive. Hence why I've linked these two together, and they will actually control the case fans. That's the important thing over there. I can just go back to the CPU profile quickly just to show you. As I said, this is the graph one. If you wanted to go to default, that was going to be BIOS. If you wanted to go to fixed, it's going to be this. Now, what you would do with fixed is, this is basically saying put the CPU fan at 50%. But I could actually just here, because it's fixed, I can manually go and change it, say, to 80 over there. And I can say save. Go up to controls here. We will now actually see there that CPU fan is on 80% actually, 2402, 2400 revs per minute. And I can just go back to the CPU temp profile over here and change that back to say 50%, or we can change it back to the graph control. I've just got to put it back onto the, I've actually just lost my, well, there we go. Now I can show you how to set it. So I had it at 30 over there, and I had it at 30 up to, so it was about 80 something over there, I think. If you left click on here, it'll add an extra sensor or two. You don't want it too wild, but you want it to go up in a couple of steps really. So just left click to add a few more. So, you know, there we go. It should now be at about 41% fan, I think. I'll just save that profile. Apply it there. And we go back to controls under dashboard. You'll see now the CPU fan is back at 30%. Controls will show you the status of the different devices. So if I go back to the CPU one again, we are on graph. So that looks good. The maximum temperature profile, well, you can of course set a couple of maxes and minimums. So if I'm not going to use here, I could have also upped the minimum so that it starts at 20, but I can't remember if there was a particular reason for that. But as I said, all these things can actually be customized. That's actually quite handy. So yeah, that's basically the profiles in a sort of a nutshell. The controls, you've also got a manual control of, say, the front fan here. You can view settings. You can set a manual speed. So I could, remember it was on 30 at the moment by default, but I could crank it up to 100. Not sure if you can hear that sound, but it is running flat out. I can hear it at the moment. It's quite loud. So that's the manual control. Okay, and it's back down again. And if you want to see which is linked between what device and what profile, if you are here on controls, you'll see, for example, at the top here, it says NVIDIA, that's the GPU, fan 1 and fan 2. They are linked only to GPU profile, the GPU profile, the same, it's the one profile that controls both. The CPU fan is linked to the CPU temp profile. But the front and the back case fan is linked to that mixed, or that combo, as I called it, CPU MVE profile that I created. The reason why, as I said, was the case fans need to look at that hard drive specifically, as well as the motherboard temperatures they must respond to. The CPU fan is really responding mostly to the CPU temp directly. So that is sort of how you can confirm which profile. So it really links to one profile. So it's either a profile that is dedicated to whatever, GPU or CPU, or it'll be a combo profile that you've created, which is a combination of two or more of the other profiles. But this is the screen where you will do sort of the linking under controls. It's dashboard and controls over there. The other thing I just want to show was also the alerts. So I've got alerts set up here, for example, for that NVMe solid state drive. I want to know if that thing is overheating. First of all, if you look here to see which source is for the alert, the source is the NVMe drive, that first one, that sensor showing 42.9 degrees. And I've basically said here, if it is greater than that, well, if it's less than 0%, it's not going to be operating actually, but the important one is greater than. If it was less than, it would trigger. And how long does it take to trigger? Well, it triggers instantly the moment it goes over there. But you can also set this to 30 seconds if you want to give it a little bit of time to sort of settle or adjust and make sure that if it's giving you false positives, for example, where the temperature is quickly spiking up and dropping, you could set this to 5 or 10 seconds or something as well over there. I think the other one, the CPU is basically exactly the same, but the fan stopped is interesting. The CPU fan, remember I said my CPU fan is actually set for 30% anyway all the time. So how I've set up this alert is I've called it CPU fan stopped. It is using the CPU fan there as the percentage, the speed in other words, as its source to check. And I've said, well, if it's running greater than 100, but that's essentially just saying ignore anything above a certain speed. That's not a problem. Unless you wanted, for example, to know if your fans are approaching 95%. But the point is, I've said here, if it's less than 5%, it will trigger this alert. And it will be for at least 3 seconds. So it can stop very briefly. But if it hasn't gone above 5% again within 3 seconds, then this alert will also trigger. So those are the useful little things. You can think about how you can apply them. You can see from these, alerts can be set on any of these things. You could have an alert set for anything really that can be monitored. It's mostly temperature though. I see there's GPU load as well, CPU load as well. But there you go. And then, yeah, the only other thing I think I really want to show probably is the settings screen. Settings, you've got a couple of general settings here. You can start a tour as well. It'll take you through what the application does. That's what I'm doing really, isn't it? You can set your time format, 12 or 24 hour, the frequency precision, whether it's going to be down to megahertz or just in gigahertz, whether you want the sidebar to collapse over there, whether you want it to be full screen or not. Well, it's on full screen now. The dashboard line size, you can choose different color themes, which can be pretty bright, and language over there as well. And for everybody, there is, I think, what, Chinese, I'm not sure which the other ones are there, but there's a couple of languages anyway. On the device side, why this can be useful is you can also blank out certain things you don't want to see if you just want to keep it simpler and maybe not have it so complicated. You can do that over there. And then the background daemon, you can apply settings on startup. That means whatever has been configured and set here, it will always make sure it's applied to that background process. You can set a device delay at startup. And that I do quite a bit just to help my initial startup of the computer, because I mean, in the first 10 or 30 seconds, I'm not going to be worrying about cooling so much really. How often must it poll? Obviously, if you're going to poll it every second or every half a second, then you're going to use up a lot more resources, as I think it's saying over there. But 2 seconds is, to me, quite a nice sort of a mix. This is really for the application programming interface. That interface, you can say if it must be compressed. This is just whether to activate for that liquid cooling driver. I don't have that. Hide duplicate devices and the drive power state as well. The desktop settings, that is really for the icon that sits on your menu or wherever your status icons sit. You can have it starting in the tray. You can have it closed to the tray. In other words, that if you close it, it doesn't close the whole application. You can set the zoom level, the startup delay, and so on. And I don't have a ThinkPad, but there's some ThinkPad settings there. And that's it. It's, it's not too complicated. I think most of it is around the tweaking and setting. You can make it fairly basic and simple to start with, and then explore a couple of options if you wish. Yeah, there's a password change. This would obviously be for your web GUI interface over there. You can open in a browser. I'll just open it manually, though, to show you that it does actually open. You can also quit the app. You can restart the daemon there. You can restart the user interface. Yeah, that's very much it, actually, I think. So let's go back to the browser, and I'll just show you the actual application starting in the browser, and you'll see it looks exactly the same as this. Okay, so we're back on the plain browser tab at the moment, and I'm going to paste in that address I showed you a little bit earlier, the web address. So now remember, if you had this running in headless mode, say on your Linux server, whether on your LAN and if it's obviously remotely on a VPS somewhere on the internet, you're going to then want to obviously have SSH'd into it with a secure tunnel, really. Don't have that wide open, but you would basically point at the host where it's running, and as I'm showing over here, port 11987. This is localhost. It's running on localhost. If I hit enter, there it comes up. And you'll see it looks absolutely identical to the application that we were running on the desktop just now. No difference. There's all your settings and so on as well. So there isn't really much difference at all. You could just have it running in a browser window if you wanted to, or have a shortcut that opens it quickly if you don't want to run the additional desktop application. But yeah, that really is sort of it. I thought I'll just show it to you because I've been finding this incredibly useful, especially when I put that NVMe drive in. I could tweak it. I've needed this very much also to make sure that unless I'm running heavy workloads, I've got a lot of silence from the machine most of the time while I'm doing my other work or I'm recording videos or that sort of thing. And it is a great way to be able to fine-tune when and how much of your cooling kicks in, you know, based on what you're monitoring, as well as having those alerts. So I think it's a very, very useful application. It's really beautifully done. And I think anybody that is running Linux at the moment should find this fairly useful. I did examine quite a few other applications I was looking at, and admittedly this was probably 8-9 months ago. And this is really what I settled on. It seemed to be the most popular and the most useful one really to use. So yeah, I hope you found that of some interest, and I hope many of you will be trying it out as well. So thank you for watching. Stay safe out there, and I'll see you in my next video.